This is the homework for 388. And for each multiplication expression, we need to sketch an area model. So here's the area model. It's a 2 by 2 because we have two terms multiplied by two terms. And then we need to write an equation showing that the area as a product, so here's the area as a product, equals the area written as the sum of its parts. So we have, we're going to go ahead and multiply these two terms. X multiplied by x is x squared. X multiplied by 2 is 2x. Then we're going to go to the second term. 1 multiplied by x is x. 1 multiplied by 2 is 2. And now we have the area written as a sum. Here are the parts, and we can combine like terms. So we're going to simplify this, and we have x squared, and then 2x plus x equals 3x, and then positive 2, so plus 2. For 388b, you're given the area written as a product. But this time we only have one term multiplied by two terms. So for the area model, we just need a 1 by 2. And now we have 3 multiplied by 2x. 3 multiplied by 2 is 6. Multiplied by x is x, so that's 6x. 3 multiplied by 5 is 15. So there are no like terms. So we don't need, there's nothing to simplify. So we have 6x plus 15. And there's the area written as a sum, area written as a product. What's happening here is you're just distributing this 3 to both of these terms. 3 multiplied by 2x is 6x. 3 multiplied by 5 is 15. So the area model is just another method in order to distribute these terms. Problem 388c, we have two terms multiplied by two terms. So we need a 2 by 2 area model. So we have 2x minus 3, 2x minus 3, and x plus 2, so x plus 2. And now I'm going to multiply 2x by x. And it might be helpful for you to put a 1 here as a placeholder. We're not changing the value. It's the identity property multiplication. Anything multiplied by 1 is itself. So 1 multiplied by x is still x. But then you multiply the coefficients. 2 multiplied by 1 is 2. X multiplied by x is x squared. Then I'm going to multiply to the second term. 2x multiplied by 2 is 4x. I'm going to go to this term, negative 3 multiplied by x, negative 3x. Negative 3 multiplied by 2 is negative 6. And now we can combine like terms. I shaded them in. Both of them are this purple color. And I'm going to go ahead and write the area written as a sum. So I have 2x squared plus 4x minus 3x is x, and negative 6, or minus 6. 388d, we have two terms multiplied by two terms, so we need a 2 by 2 area model. And we have x multiplied by y is xy. X multiplied by negative 1 is negative x. And if you forget, here's Pizza Bob, the rules for multiplying and dividing integers. So a positive multiplied by a negative will equal a negative. So x multiplied by negative 1 is negative 1. And now we go to the next term. Negative 1 multiplied by y is negative y. Negative 1 multiplied by negative 1. So a negative multiplied by a negative is going to equal a positive. So we have positive 1. Here we don't have any like terms to combine. So I have negative x plus xy minus y plus 1. 388e, I have one term multiplied by two terms. So I need a 1 by 2 area model. And now I have negative 2 y multiplied by y. And again, if you like to put a 1 here as a placeholder to remind you, okay, this is negative 2 multiplied by 1, which is negative 2. Y multiplied by y is y squared. Then we have negative 2y multiplied by positive 3 equals negative 6y. We don't have any like terms to combine, so we have negative 2y minus 6y minus 6y. Area written as a product equals the area written as the sum of its parts. 388f, I have 2 terms multiplied by 3 terms. So I need a 2 by 3 area model. I need 2 boxes here because I have 2 terms, and I have 3 terms here, so I need 3 boxes. And now I'm going to go ahead and distribute the negative x multiplied by 3x is negative 3x squared. Negative x multiplied by y, negative xy. Negative x multiplied by negative 4, negative 4x. Now I'm going to go to the second term. 1 multiplied by 3x is 3x. 1 multiplied by y is y. 1 multiplied by negative 4 is negative 4. Now I can combine like terms. I have 3x and 4x. These are the only like terms. All the others I cannot combine. They are not like terms. So I have negative 3x squared, 3x plus 4x, 7x, negative xy, plus y, negative 4, negative 4. When you have a lot of terms here, sometimes it might be helpful to cross them out as you write them or combine like terms so you don't forget one. So again, what this area model does is it helps me organize my terms to do distributive property. So here I would distribute negative x multiplied by 3x, negative x multiplied by y, negative x multiplied by negative 4. And here I would be doing the same thing, but it's just organizing my terms to make it easier for me to do the distributive property. And it makes it so I'm less likely to not forget one of the terms when I'm distributing to each of them.